will be missing. So, Hamilton? I bet it's where's that?
So,
Are you going to Newland?
this is what I'm gonna do today, these sections. And all that's left this semester is I'll do a little bit about solubility from this chapter, and I'll say at least a little bit about acids and bases, and then that'll be it. This we did already. But I'll go through molarity again because it was new. And hopefully we'll have a lot of time to review for test 3. And hopefully we'll have time to review for the final. Okay, concentration as percent solution. So concentration in 8.6 is about concentration. In dilution, 8.7, that's when you add pure solvent to decrease in concentration. I'll get to that in a minute, but that's the classic formula for dilution. M1V1 equals M2V2. I'll tell you about that later. But that's dilution. But percent concentration comes in 2 forms, and we denote it like this. So this is the symbol used. This first one, it's the M means mass, and the V means volume. And remember that you have a solute, the thing that's dissolved in, and the solvent, the thing that has the other thing dissolved in it. So when we say M over V, we're saying the solute, or I should say this, I should say amount of solute divided by the overall amount of solvent. In this case, the amounts are, that's what the M and V means. So mass of the solute over volume of the solution. Overall volume of the solution. And the V, so that's what that is. And that, and the volume over volume means so you can dissolve a solid in a liquid, which is what this is referring to. And you can also dissolve a liquid in a liquid, which is what this is referring to. But notice the volume of the solution. This is just a weird twist. But in this case, volume of the solution equals volume solvent of solid. The overall volume in the denominator here for this one is the volume of this, the volume of the solute, plus the volume of the solvent. Does that make sense? But I'll go through problems on these. So that's just what that's saying there. N times 100%. The formula for these is I'll show you. That's the formula in in this gray box here, but let me just solve the problem here. 0.35 grams in 25 milliliters. These are all in milliliters. Grams in 25 milliliters. So, well, they solve it for you, but you would just go 0.35 divided by 25 times 100, and you get 1.4. It's two significant figures, that's 2, that's 2. So 1.4%. Simple formula, right? This one down here, 4.3 grams of ethanol. You can have more than one thing dissolved in a solution. This one's saying 4.3 grams of ethanol in 30 milliliter solution. And this has another thing, this antiseptic, 0.021 grams. So two different concentrations you can calculate there. And these would just be 4.3 grams, 30 milliliters. And 0.021 grams, 30 milliliters. My calculator says, but this is two significant figures, so it's, when you include the percent sign. That one's 14%, 0.021. This one is, two significant figures, two significant figures. And I guess I'm just going to do a bunch of these problems. This says 1 liter, but we do this in milliliters. So 1 liter is 1,000 milliliters, so 35 grams. Problem 8.11 is 35 grams, 1,000 milliliters. I think that comes out to 3.5. Make sense? All right, the other one, volume percent. So there's the gray box with that definition. If these are tricky at all, it's the idea that the denominator is the solute plus the solvent. But this is saying 750 milliliter bottle, so that's the overall. That's solute and solvent together, and 101 milliliters of ethanol. So the volume to volume percent for this one okay, there's no decimal there, so that's two significant figures. And 101 milliliters. Got 13.46. Two significant figures, 3, so I would just say 13%. Sure, I calculated that right. How'd they get 14 and I got 13? As far as I'm concerned, that answer's wrong. Because when I do that math, I get 13.466666. This one you'd have to convert fluid ounces to milliliters, but I'm not going to give you a problem like that. Okay, a variation on this type of problem. A saline solution used in intravenous drips, sample problem 8.7. So 0.92%, how many grams are contained in 250 milliliters? You just use the same formula. But I would set it up like this. Equals times 100. I tested these before class. Milliliters, no decimals. And just solve for x. I would just always set it up just like that, solve for x if it's something like this. So I would divide 0.92 by 100 to start. And then multiply both sides by 250. And my calculator says x equals, and that'll be in grams. Two significant figures, so really it's 2.4 grams. So just solve for x. They've got 2.3. Have I lost my mind? 0.92 divided by 100 times 250. What did I do different? 0.92 divided by 100. Yeah, I miskeyed somewhere. It's just 23 grams. 2.3. What is the volume of a 5% weight to volume solution of ketamine that contains 75 milligrams? Any good markers left? So you're gonna need that for the conversion. So you have it in grams. Milligrams and 5%. X. What bar? See, we solve that one that way. So just this part gives me this is that number. Divided by 100. I have to invert both sides, at least algebraically, this is how I would do it. Invert both sides so you have X milliliters on top. Now 1 divided by 0.05 is 20. And now I can just multiply by 0.075. Really? Twenty times 0.075. I just can't use a calculator this morning. So that gives me X equals 1.5. I think. Yes, 1.5. Good. Problem 8.8. Go ahead and set up this fan because I can already feel the heat. I'll solve this next one. .5%. So it's two significant figures. What volume would you suggest to get 1,000 milligrams? They put a decimal here, so that means that's four significant figures. And that's exact. So that's how many grams we have, 1.000. That's what 1,000 milligrams would be. Divide by 100. So divide both sides by 100. Invert it. Actually, that wouldn't be there. Divide that percent by that percent. It takes away the percent sign. You see what I did? I just inverted both sides. 1 divided by 0.005. 200 here. That should be back there. All right. And now multiply both sides by 1. That's what did I do here? 2 significant figures. I actually have to use scientific notation because this 0 is significant, this one is not. So putting a decimal here or not doesn't solve the problem. It really needs to be in scientific notation. So it's these 2 that are significant. There's 4 here, so I'm going to multiply both sides by 1, which is going to leave the 200. And it needs to be 2 significant figures. So I'd actually have to go they don't give us the answer here. I'm going to skip parts per million. All right, and we can review molarity. Let's review molarity. Okay, what's the molarity of this solution? 108 grams of glucose and 2.0 liters. Okay, they give us this. I'm pretty sure I did this very problem the other day. But if the grams per mole for glucose is 180.2, grams per mole, so 108 grams. You guys do those molarity problems online? You guys do those quizzes, don't you? I can go look, see. I know some people do. So now we're at 8.6. And this is problem 8.10. Need the grams per mole. So you have moles on top. 180.2. 2 liters. That will end us on moles per liter. See that? .108 divided by 180.2 divided by 2. 3 significant figures, 4, 2. My calculator says 0.29967. But it's 2 significant figures there, 4 and 3. So I'm keeping those 2, and this 9 rounds it up, so I have to go 0.30 moles per liter. Also written this way. 0.30 molar solution.
a solution with 0.30 molarity. So here we're talking about NaCl, practice problem 8.10, and it tells us the grams per mole for NaCl. Let's just pick one, 12.0 grams in 2 liters. That's in 2 liters, so I'm doing D. 12.0 grams in 2 liters. That should do it. This one would be and 2.0 liters. So it's 2 significant figures again. My calculator says, there's my 2 significant figures, 0.10. Also written like that. Problem 8.13. .00 grams. The grams per mole of acetic acid is 60.05. And 100 milliliters. It's got to be on the bottom. 100 milliliters. And then so I've got to get the conversion factor in there to turn it into liters. Molarity is specifically in liters, no other volume. 5. If I did that right. My calculator says 3 significant figures, 4, and these are all no. Yeah, 100 with the decimal, so that's 3 significant figures right there. So we've got 3 there, 4 there, 3 there, so we need to be in 3. So we'll keep those. Moles per liter. Molarity. Need to get some new markers. What volume in milliliters of a 0.3 molar solution of glucose contains 0.25 moles of glucose? So sample problem 8.11. Turn that M into moles per liter. write it this way, because this is the way you're gonna use it. That's a 1. This is how you're gonna use it in the math problem. And, 0.0 moles. We're gonna have moles on the bottom, liters on top. And it's asking for milliliters. So I've got to go from liters to milliliters. That's a 1. Moles cancels, liters cancel, and we ended up in milliliters. Calculator says two significant figures, 2, so it's 83. Reviewing molarity. They gave us the grams per mole of glucose earlier, 180.2. You would need that to solve this one. Practice problem 8.11. How many milliliters of a 1.5 molar glucose solution? Okay. 0.15 molar. How many moles? Okay. So take this, and go liter. That's what I'm using right here. Makes sense? And now milliliters cancel, liters cancel, and we get the number of moles. $710 times 0.15 divided by 1,000. That's what the calculator says. That's two significant figures. Those are exact. That's 2. So I'm keeping those. 0.5 moles. We didn't need the grams per mole for that. How many moles of NaCl are contained in each volume of aqueous NaCl? Okay.
I realize that probably is not, but I think
I'm gonna skip this one because I don't know what this little typo is about. Let's do B. So if you have 2.5 liters of this molarity, how many moles is that? So that's
find things and have
doing B here, 2.5 liters of a 0.25 molar. So whenever you see in a problem, you see that, go ahead and turn it into because this is the way you're going to use it in the calculations. And that's what I've got here. That's what I've got here. .5 times 0.25. That's what my calculator says, but these are two significant figures, so I'm keeping those. All right, how many grams of aspirin? We're gonna need we're using 180.2 again. But that's what they gave us for glucose, isn't it? But, okay, so just to say it out loud, sample problem 8.13. You're given 50.0 milliliters. And we're also given and we're being asked for grams. We're also going to need grams per mole. And that's everything we need. Being asked for grams, so convert to liters. Milliliters cancel, liters cancel, moles cancel, and we'll be told how many grams of aspirin. That's what my calculator says. That's two significant figures. That's 3. And that's 4. So I'll keep two significant figures. .45 grams should be the answer. 0.45 grams. All right, dilution. Okay, 8.7 dilution. For dilutions, just always remember M1V1 equals M2V2. You could write this as this specifically means molarity, but you could also say for concentration, because those percent concentration problems, you can still solve it the same way. But I'll do it for molarity, specifically for molarity. So if I have a beaker and I have a certain number of moles dissolved in it, it has a certain concentration. If I need something that's less concentrated than that, all I have to do is add some of the solvent. Let's say it's water. Let's say it's salt water, NaCl. And I need a less concentrated solution. All I have to do is pour some pure water in there, and it's going to be less concentrated. Does that make sense? So that's what a dilution is. You're diluting it with solvent to make it less concentrated. The ones here are my initial state, and the twos here are expressing what I have after I've added some solvent. So I have my first molarity, my next molarity. This will be this M will literally be a smaller number than this M. And this volume is going to be a larger volume than this one. Yeah, that's right. So this will be a smaller number than this, but this will be a bigger number than this. So when you do these problems, you just have to identify what's volume 1, what's volume 2, what's molarity 1. You always see this phrase too. Let me write it. 5.0 milliliters of a 3.2 molar solution. I'll have to be good. So these two, when you see this phrase, those two go together either on this side or that side. There's your molarity and there's your volume. And it's saying that's our initial state. You're diluting a solution that's described this way. So these are the ones. So V1. So we still need M2 and V2. So diluting to 40 milliliters. There, now we have everything. You're always going to get 3 out of 4 of those variables in your solvent for that water. In any one of these. So they gave us this in 3, this is 2, and that's 2, so my answer is going to be 2. But I'm essentially just doing this. I'm just dropping the units off for simplicity. .40. That's the new concentration. Practice problem 8.14. What is the concentration of a solution formed by diluting 25 milliliters of a 3.8 molar glucose solution? So here, 25.0. What to do, my markers get out. So if you can identify M1, V1, M2, V2, and just plug them in. Um, M1 is 3.8, V1 is 25.0. So it's 3.8 times 25 divided by 275. Well, my calculator says, but we're keeping two significant figures because of this. Zero point 35. I have in here under quizzes some of these percent concentration things. And, oh, that's right, I'll make this visible. Percent concentration, molarity we did the other day. This one that says dilution. You look at that one, it says that, because this, the bank of questions that I have that I can put on D2L that the publishers made, just doesn't have many of those. I think there were 2 that I found. So, to practice these, use 7, 7, 8, 7. So these questions at the back of the chapter, 8.7, whatever I put there. 7, 8.77 and 8.78. You get the answers to these, so I'll leave those, an odd one, but I'll do 8.78. So there's essentially 8 problems on this, but that bank of questions I have really barely touches these. So we'll practice with these. All right. These are solutions being prepared. So what you're looking at there is to prepare to make this 45 milliliters of a 4.0 molar solution. That's M2 and V2, and that's M1. So in this case, markers are going to just give out. Okay, I'm doing 8.78. M1 is 5.0. V1 is what we're being asked for. So for these 45 milliliters. 45 without that, 45 milliliters. So the answer here is four times 45 divided by 5. I probably should have all my units in there, which would make this come out in milliliters. The next one, B. Milliliters, 0.5, and this is still 5. I know. There's milliliters. Should we do those? Oh, I think I'm good. Should I got through all that a lot quicker than I expected to. What have I done? Just go back here. I think I should go over those anymore. I didn't really prepare anything else. I don't have any questions up on this yet, but I'll at least introduce this topic. Solubility. So I will talk more about solubility Thursday. I want to have this so we can look at it. I don't mind giving you that on a test. So this is just a matter of know how to use this chart. Let's see. All right, so if you're given, these are all ionic compounds, and generally most ionic compounds dissolve in water. So, and just for vocabulary, realize those ionic compounds are a solute, and water is the solvent. So, the sodium phosphate, Na3PO4, is that soluble in water? Well, you look down here, let's see, Na, this is saying group 1A cations, that's the first column. So any ionic compound that has these is soluble. So this one that's got sodium, that one's soluble in water. This one that has K, that's also soluble in water. That's how you use this chart, because those are listed here. NH4, I probably didn't say much about NH4. We did ionic compounds, but that's one of the polyatomic ions. It's a molecule that looks like that, and we put these brackets on it to give it its charge, but it's a +1 charge. So anything that has ammonium is soluble in water. But since I'm going to give you that chart, it's just a matter of you being able to read the chart to answer these. So K shows up down here, Na shows up down here, so these two compounds are soluble in water. Magnesium, though, you don't see magnesium anywhere, and you don't see the phosphate anywhere. So the magnesium phosphate is insoluble in water. If you put that in water, it'll just float down to the bottom and sit there as a solid, and you don't have a solution. Give us more of it. Okay, there's some more. All right. Li2CO3, lithium carbonate. Is that soluble in water? It's listed here, so it is. I mean, lithium is listed here, right here in Rule 1. So that is soluble in water. MgCO3, you don't see Mg anywhere down here, so that's not soluble, magnesium carbonate. This is potassium bromide. K is right here, so that is soluble. Lead sulfate. Here's the sulfate right here. And it's saying sulfates are soluble except for these few exceptions right here. So PbSO4, there's the Pb, so that's an exception, that is not soluble. This Rule 2 is saying all sulfates are soluble except for sulfates that have these as their positive ions. You see that? So that one is not soluble. Calcium chloride, calcium doesn't show up down here, but chloride. So Rule 2 here, any of the halides, this is saying these are always soluble. Anything with chloride, anything with bromide, anything with iodide, those are all soluble except for these few exceptions. And that's calcium chloride, and that's not in the exceptions, so calcium chloride is soluble. So I'll give you this chart, just understand how to read it and use it. Magnesium chloride and calcium chloride. Neither magnesium nor calcium are in these exceptions, so both of these two are soluble. Temperature effects. Well, I got through all that way quicker than I expected to, so I suppose I would rather not start general features of solubility. So I'm just gonna have to eat the 15 minutes. All right, so I've given you problems on dilution, but really just the ones from the back of the chapter and the ones in the chapter, I guess, because there aren't any good questions like that in the data bank. And the percent concentration, I reviewed molarity, so make sure you can do molarity calculations. Yeah, we'll just eat the 15 minutes. Use this chart. I don't have any questions up on these, so don't worry about those.